All right, so that argument that I just gave you, there are actually two probably equally popular ways to set it up. So you're looking at one way right here in blue. This is if you translate "I don't need a jacket" as squiggly Q. But you don't have to translate it that way. So here's another equally popular way to translate the original argument. So decide which way you set up the argument, and then I'm going to really quickly run through both truth tables. So if you set it up the blue way, you're going to have to wait a moment. But if you set it up the pink way, here we go. I'm going to grab a new pen, if I can do that. All right, so I'm going to take my first premise. That's an if-then statement, if P then Q. So it's only false when the first part's true and the second part's false. So it's false here and here. In all the other cases, it's true. And then I'm going to look at P and R. So I'm looking at this column and this column, and I'm putting an and in between those. And statements are usually false. They're only true when both parts are true. And then now I'm going to do Q. So Q is nice. I just have to copy the Q column exactly the way that it is. And I'm going to grab a highlighter really quickly because I'm going to look at rows. You know what? I'm going to grab pink. It'll just be all pink for this problem. I'm looking for rows that have all true premises but a false conclusion. So I see the top row has two true premises, but it has a true conclusion. Oh, and there's not even any other row that has two true premises. So this is a valid argument. I'll put my highlighter back away and answer the question. Is the argument valid or invalid? Valid. How did I use the truth table to arrive at my answer? So the top row, the first row, is the only one with all the premises true. And in that row, the conclusion is also true. All right, so now if you look at it this other way, where Q represents "I need a jacket," and so that first premise ends with squiggly Q, and our conclusion of our whole argument is squiggly Q. How would this look? So now my first column is going to take a little more work, at least for me. So underneath this P, I'm just going to copy down all the P's. This helps me. And then underneath squiggly Q, I'm going to reverse all the Q's. And I'm going to put them together with an if-then statement. If-then statements are only false when the first part's true and the second part's false, like right here in the top row and here. Okay, and then P and R, I'm just putting these together with an and. So and statements are only true when both parts are true. So that's going to happen here and here. But in all the other rows, it's going to be false. And then in my last column, I'm doing squiggly Q. So I'm going to be reversing all these Q's. So I'm just reversing all of these. I'm not even going to grab a highlighter this time. I know the argument's valid. It was valid when I structured it the other way, so it has to be valid when I structure it this way. I just have to figure out which rows give me my proof. So I'm looking for rows that have all of the premises true. You know what? I will grab my highlighter. Okay, where are all my premises true? Right here. Yeah, that's it. And in that row, my conclusion is also true. So my explanation would be exactly the same as the explanation I gave last time. The argument is invalid because the third row is the only row where all the premises are true, and in that case, the conclusion is also true. There you go.